Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we are going to start talking about systems of linear equations. And there are three methods of solving a system of equation. And we're going to learn the first one of those today, which is solving by graphing. But before we start learning how to solve a system by graphing, let's talk about what a system is. A system of equations is a set of two or more equations, period. That's it. It is used when you have two or more related unknowns. So what's happening here is before we were dealing with just a regular linear equation where you had one variable that was unknown, now we're talking about two different unknowns. A linear system consists of two or more linear equations. Please remember that when we're talking about linear equations, we're talking about equations in the form of y equals mx plus b, where x has an exponent of 1. Now, a solution of a system is a value or set of values, ordered pairs, my x comma y, for the variables that make all of the equations true. In order for there to be a solution to a system, that solution has to work in all of the equations that I give you, or that the book gives you, or that the test gives you, or that life gives you. It must be a solution to all of them. If it's a solution to one but not the other, I'm sorry, but it is not accurate. The solution of a linear system is the intersection point of the given linear equations. If you look here at this example right here, gentlemen, I have these two lines. I have y equals 1/2 x plus 5, and I have y equals negative 1/2 x plus 3. The solution is negative 2, 4. Why? Because that is the point where both graphs intersect. Now, let's just go back in time real quick, and let's just review how to graph these. The first one, y equals 1/2 x plus 5. Well, my y-intercept is 5, so I go 1, 2, 3, 4, 5. My slope is up 1 over 2. So up 1 over 2. Let's go backwards. Down 1 over 2. Down 1 over 2. Down 1 over 2. It should be kind of over here. Okay? And that's my line. Fuagada. Now, the other one. The second equation. Y equals negative 1/2 x plus 3. So my y-intercept is 1, 2, 3. Right there. My slope is down 1 over 2. So down 1 over 2. Down 1 over 2. Let's go backwards. Up 1 over 2. Up 1 over 2. And lo and behold, the point of intersection is right here, which is my negative 2 comma 4. The beauty of these kind of systems is that you can check the answer, guys. Everyone is human. I make mistakes all the time, every day. I try to not repeat them, but it happens. So check it. If x is negative 2, let's plug it in. 1/2 times negative 2 is negative 1. Plus 5, that equals 4. It works. Plug it into the second equation now. If x is negative 2, negative 1/2 times negative 2 is 1. 1 plus 3 is 4. It works. This solution works for both equations. That's the solution of the system. Yes, sir, my brother. Will the solution always be perfect? I am going to do my best to always make sure that it is perfect. By that I mean no fractions. It's kind of difficult to estimate fractions, right? So let me rephrase that answer. When I'm asking you to solve by graphing, they will be perfect. But in the other systems, the other methods, substitution and elimination, you're going to have fractions. You're going to have decimals. It's just going to happen because you can do it mathematically. But if you're graphing them, I'm going to do my best to make sure the solutions are whole numbers, or rather integers at least. Okay? Thank you, gentlemen. So that's it. That's the lesson today. So let's talk. Find the solution of the system by graphing. Okay, what do I have to do? I have these both in standard form. Can I use the x and y intercept method for the first equation? No, because negative 3 is not a factor of 8. So what do I have to do here, gentlemen? solve for y. So I'm going to add 3x to both sides, which gives me 2y equals 3x plus 8. And then I'm going to go ahead and divide by 2. So my first equation is y equals 3 halves x plus 4. I'm going to do that in green. I'm going to go ahead and graph it right now. My y-intercept is 4, so I go 1, 2, 3, 4. My slope is 3 over 2, so I go up 1, 2, 3, 1, 2 to the right, 1, 2, 3, 1, 2 to the right. Just go backwards, down 1, 2, 3, 1, 2 to the left, down 1, 2, 3, 2 to the left, and connect the dots, and that is my line. Now, I can use the x and y intercept method for this. However, I'm going to implore you not to do that. Because the x and y intercept will give you the x and y intercept, but sometimes it doesn't go far enough. Well, but you know what? In this case, it will work. What's the x intercept when y is 0? So negative 1, 2, 3, 4, 5, 6, 7, 8. What's the y intercept when x is 0? Negative 4, which is right here, right? So in this particular case, it worked. Now, why could it not work in the future? Maybe they intersect over here, and if they intersect over there, you're not going to be as accurate. Okay, so check it out. But that's it. My solution here is right here, the intersection point, which is 0, 4. Very good. Let's plug it in and see if that works. Negative 3 times 0 is 0. 2 times 4 is 8. That works. 0 plus 8 is 8. Whoa. It's negative 4. No, right here, guys? It is. Maybe I should learn how to read. Maybe I should learn how to read. So that is an epic fail on my part. And I apologize. There's no excuse. Pay attention, Mr. Morrow. Let's do it again the right way. Y equals 3 halves x plus 4. 1, 2, 3, 4. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. And okay. Now I'm not going to do it with x and y intercept. I'm just going to solve it. I got here, we'll do it in blue. 2y equals negative x minus 8. Wow, I'm so embarrassed. That was pretty silly. And I apologize. No excuse. Negative 1 half x minus 4. Hello? So negative 1, 2, 3, 4. Negative 4. Down 1 over 2. Down 1 over 2. Let's go backwards because I got to find an intersection point. So up 1 over 2. Up 1 over 2. Up 1 over... Whoa. What is going on with me today? What is going on here with me today, guys? This is 1, 2, 3. So down 1, 2, 3 over 1, 2. What is going on with me today? One, two, 1, 2, 3, 4. Down 1 over 2. Down 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. There you go. Wow. Okay. Yay! That was a difficult thing to do here, apparently. So my solution here is 1, 2, 3, 4. So negative 4, negative 2. Let's see if this time I did it right. Negative 3 times negative 4 is 12. 12 minus 4, yeah, it's 12. 12 minus 4 is 8. That works. And then negative 4 minus 4 is negative 8. Woo, finally. Jeez, Luis, don't do what I did. How about that? Do it the right way. I don't know what happened to me, and I apologize. Thank you, my brothers. Okay, that was pretty embarrassing. Number 2. Let's see. Now, you can classify systems of linear equations by the number of solutions that they have, guys. There's what's called consistent systems and inconsistent, okay? Consistent means that there's at least one solution. If you have what's called a consistent independent system, An independent system has only one solution. How can you remember that? Think of independent, individual, one individual solution. It's when you have exactly one solution. Dependent systems, okay, has infinitely many solutions because the two equations represent the same exact line. If you have an inconsistent system, that means you have no solution. And graphs for an inconsistent system are parallel lines. We learned about parallels already. Parallel lines have equal slopes. So when you see that the slopes are the same, but you have different y-intercepts, that's inconsistent. When you see that the slopes are the same and the y-intercepts are the same, that means that they're the same line. That's dependent. When you see that the slopes are different, they're going to have one solution that's independent. You had your hand up, my brother?
No, yeah, I was gonna ask you if it was like parallel lines, or the inconsistent system.
Inconsistent will be parallel lines because there's no solution. They never intersect, my brother. Thank you, sir. Okay. So, for example, intersecting lines. Intersecting lines, guys, has one solution. It is consistent, and it's called independent because it has one solitary individual answer. Here again, the slopes will be different. If you have coinciding lines, that means lines that are the same, you have infinitely many solutions because it's the same line. It is still consistent, but it is consistent dependent. The line is itself. That means that both lines have the same slope and they have the same y-intercept. If you have parallel lines, that means you have no solution because parallel lines have equal slopes. They never intersect, and it is called inconsistent. I'm going to ask you very nicely and gently right now to definitely learn these because this is going to be on your quiz, and it is going to be on your test, and it is going to be on the SAT, and it is going to be on the ACT. So learn them. Learn them today, right now. Independent, one solution. Dependent, infinitely many solutions. Inconsistent, no solution. Independent has different slopes. Awesome. Dependent has the same slope and the same y-intercept. Awesome. Inconsistent, no solution, has the same slope, different y-intercepts. Does that make sense?
Yes, sir.
Okay. So without graphing, is the system independent, dependent, or inconsistent? Well, first thing you always want to do here, guys, is solve each of them for y. Put the equation into y equals mx plus b form. Okay? So let's solve for y. Let's do this guy in red. So I've got 4y equals 2x plus 6 divide by 4. So y equals 1 half x plus 3 halves. Now, let's solve for this guy. Let's go ahead and divide by 8 to both sides. So y equals 1 half x minus, minus 3 halves. Okay. So once you've solved them for y, now it's basically just a matter of comparing the slopes. If the slopes are the same with different y-intercepts, then the lines are parallel and therefore there is no solution. If the slopes and the y-intercept are the same, then the lines are the same and there are infinitely many solutions. If the slopes and the y-intercepts are different, that means not equal, then the lines are independent and there is one solution. So right here, guys, what would this be? So no solution. So would it be dependent, independent, or inconsistent? This would be inconsistent because the slopes are the same and you have different y-intercepts. Does that make sense, gentlemen?
Yes.
You promise? May I continue? Yes, sir.
Um, the is it just a coincidence that the numbers above, or that the bottom ones are multiples of the numbers on the top? Would that be a telltale for no solution?
No, you cannot do a telltale for no solution. There is no shortcut here. You have to solve for y. Okay? The only way that there is a telltale is if both of them are equal. If you had 4y minus 2x equals 6 and then 4y minus 2x equals 6, then you don't have to solve. They're both equal. Thank you for asking, sir. Great question. Without graphing, is the system independent, dependent, or inconsistent? Let's solve for y. This guy here will become y equals 3x plus 4. Solve for y here. This is negative 1/3 y equals negative x plus 1. I get rid of this negative third by multiplying by negative 3 to both sides. So I get y equals 3x minus 3. So what do I have here, guys? These are my two equations. Is this consistent, independent, dependent, or inconsistent? This is inconsistent because they have the same slope but different y-intercepts. So this is inconsistent. If they had the same slope and the same y-intercept, then it would be dependent. If they had different slopes, it would be independent. Without graphing, is the system independent, dependent, or inconsistent? All right, let's check it out. Let's solve for y. When I solve for y here, I subtract my 2x and then I divide by 3. So y equals 2/3 x plus 1/3. It'd be negative 2x, yes. Because I got to subtract the 2x and then I divide by 3. Thank you. Over here, this would be y equals negative 4x minus 3. Looking at the slopes and the y-intercept, would this be dependent, independent, or inconsistent? Independent. There's going to be one solution. Why? Because the slopes are different. If the slopes are different, you're always going to have at least one solution. Does that make sense, gentlemen? Are you sure? May I continue? Okay. Find the solution of the system by graphing. Maybe I can do it correctly this time, the first time. So let's first of all solve for y here. So I got x minus 2y equals 4. I'm going to subtract x to both sides. I got negative 2y equals negative x plus 4. Divide by negative 2. So y equals 1/2 x minus 2. Let's go ahead and graph that. My y-intercept is negative 2. My slope is 1/2, so up 1 over 1, 2. Up 1 over 1, 2. Down 1 over 1, 2. Down 1 over 1, 2. You definitely want a lot of points on these types of questions, guys, because you don't know where they're gonna intersect. That's exactly right, my brother. You don't know how far it's gonna go. So let's do another set of points. Let's go again up 1 over 1, 2, and then let's go down 1 over 1, 2. Let's make it as many points as possible because, again, you don't know where they're going to intersect, gentlemen. Now let's go ahead and solve for this guy right here. And that would be easy. I just subtract 3x to both sides. So I get y equals negative 3x plus 5. My y-intercept is 5, so I go 1, 2, 3, 4, 5. And my slope is down, negative 3, so I go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Hey, and in this case, 1, 2, 3 over 1. I don't have to go any further because I know that my solution is right there at 2, comma, negative 1. Let's test it, though. 2 plus 2 is 4. It works. 6 minus 1 is 5. It works. Does that make sense, guys? Because I got time. We're done. Any questions at all? Yes, sir, my brother. Thank you.
On a test or a quiz, would you want us to keep going like how you kept going with the slope, or can we stop?
Okay, great question. No, great question. What my boy asked was, do we have to continue with the blue line, Mr. Morrow, or could we have stopped right there? Okay, technically you can stop there, but always go one more further just to go ahead and complete the line. So 1, 2, 3, just one more just to complete that line. But technically what you asked, yes, you could stop. Yes, sir. Any questions at all on independent, inconsistent, or dependent? On graphing? We're good? Thank you for a great class. God bless you all and have a wonderful day. Hope you learned a lot.